Hello, so today we are going over several basic drafting techniques, settings, and options with Siemens NX10. Here I have from a previous lesson a modeled electrical cover. Jumping into it, we will go to Application into Drafting mode. From here, we're giving an option to choose what sheet size we would like. For this particular component, SC size will be suffice to fit it into a nice 1:2 ratio, so we will use that one. For first issued, there was none available. Drawn by Derek W. Checked by not available. Approved by not available. Okay, so that's for the title block down here in the bottom right corner. The view creation wizard pops up. It's a very handy tool, but for this we won't actually use a more specific base view. From here you can see the size, so we want to scale it down to a 1:2 ratio, and we can start with the top view. Usually for basic isometric drafting drawing, you would usually use a top, front, and a right view of the component, but to try to save as much space and make it as efficient as possible, we will actually realize intuitively that this is the front view and it's the exact same as the right view, so there's not really any information we can get pertaining to that particular notion. So we will actually be creating a section view. You can actually go to the button here, or you can click on the view, right click it, and say add section view. From here you will want to center it approximately right to the middle. It will do an inferred hinge to figure out which one you would like. So we want that one. So you can see that the section view chose C for the first label, and it should be A. So you can right click on the section center line, go to settings, and you can view and change the label to A, like so, and it changes the section views label also correspondingly. Now to add a right view of a 1:2 same ratio, and now we can add a isometric view top right corner like so, and since this is a pretty small area, we can add a detailed view by choosing the center as the midpoint and the boundary point like so, and placing it relatively close to the section right there. It's good. From here you will add all the center lines after the views have been in by annotation, opening up the checkbox and adding 2D center line. For the type, we'll do point by point. There's from curve to curve, but so we can see that this is a center line for this view, and for the extensions we will have 0.25 for each side, which is correct. Good. Now this is the same front view of it, so they go together from the center midpoint to the center midpoint. Good. Now we are ready to start putting all the rapid linear dimensions in, and we can start by doing so quickly. From here I like to work from top to left to right bottom, so we will start from the top. Now you have to always be careful for which points you are choosing to make sure everything is exactly the way it should be. This. It's vertical dimension, and get the holes positioned. that's about all those linear dimensions. Let's pull this one down. Just a tiny bit. Now we can start at the next view. For here, you always want to try to choose the tangent point. It's pretty far down the list, surprisingly, but it's the exact point we would like. Yep. Okay. Now for this one, since you can see this is the hatching view, it's a 0.25 thickness, so we are going to put a suffix by double-clicking on it. We get another option of the settings, but it's a more user-friendly base. And from here, we can actually put THK, and that will say it's a uniform thickness of 1/4 of an inch. Of the linear dimensions for that view. That's all the dimensions for that view. Now we can go on to the detailed view. We only need this linear dimension, 0.2. We can go on to the next view. We will give the height of the ellipse to the bottom face of its base. So we'll come dimension our latch. And after all the linear dimensions are in, this is when I like to start with my radial. Within this setting, you can change the method of measurement to radial diametral hole call out, and so for the hole, we will use the method hole call out. It actually selects every one of the holes, so, but you do have to double click it and add a prefix to say there are 6, as well as the radius to this dome. That's all for that view. From here we will be inserting a angular dimension. There's two selection modes, objects, vectors, and objects. So we want to start with one object, this angle, then switch to a different vector and object mode, select our second object, select our vector, and we get our corresponding angle. Views. Now the views are fully dimensioned. Now we can come and change any type of significant digits that we require or would prefer for any parts of the component. So for this one, I'm going to say we want 0 significant digits, so it's a whole number and so forth for this one. And from here, we are also able to start tidying and cleaning up the formatting of all of the intersecting lines. Like for this angular dimension, how there's two radiuses intersecting through its linear dimension, we can right click on it, go to settings. From here we get an array of settings between line and arrow, heads, extension lines, and breaks, which is exactly what we want to do. Create a break between any intersections for other dimensions. Perfect. From here, the last thing to dimension are the ellipse, which we will be putting into a side note in the following format. Note 1, all ellipse edge blends are 0.25 inches. Make this 2. And from here, you can fit the screen, double check everything, go to File, Plot. We'll be exporting the file as a JPEG into the following folder. And that concludes our draft.